The humid Florida air on December 6, 1957, was thick with anticipation. At Cape Canaveral, a slender, elegant rocket stood poised against the pale sky. This was Vanguard, America's great hope. It was more than just a machine. It was a symbol of scientific ambition, of peaceful exploration, a testament to American ingenuity. Hundreds of journalists had gathered, their cameras and microphones aimed at the launch pad, ready to broadcast this historic moment to a nation holding its collective breath. This was supposed to be America's answer, the moment the United States finally joined the Soviet Union in the vast, cold emptiness of space. The countdown echoed across the Cape, a rhythmic pulse of progress ticking toward destiny. 10, 9, 8. Each number was a drumbeat of hope, a step closer to piercing the veil of the atmosphere. On television screens across the country, families gathered in their living rooms, watching the grainy black and white image of the rocket. This was not just a scientific endeavor, it was a deeply personal and national drama playing out in real time. The pressure on the engineers and scientists of the Naval Research Laboratory was immense. They carried the weight of a nation's pride on their shoulders, a burden as heavy as the rocket itself. Then came the moment of ignition. A brilliant orange and yellow plume of fire erupted from the base of the Vanguard rocket. For a breathtaking instant, it was a picture of pure power and promise. The rocket began to lift, slowly, majestically, rising just a few feet off the launch pad. A cheer began to ripple through the crowd of onlookers. This was it. This was the moment of triumph. America was on its way to the stars. But the triumph was tragically short-lived. Just 2 seconds into its flight, at a mere 4 feet of altitude, the symphony of power turned into a cacophony of failure. The rocket's main engine lost thrust. The graceful ascent faltered, and the Vanguard vehicle, heavy with thousands of pounds of volatile fuel, began to settle back down. It tilted, its elegant spire now looking like a falling spear. It crashed back onto the launch structure with a sickening crunch, rupturing its fuel tanks. A massive, fiery explosion engulfed the launch pad in a hellish inferno of smoke and flame, a funeral pyre for America's space-age dreams. To understand the crushing weight of that December explosion, we must rewind the clock just 2 months. On October 4, 1957, the world changed forever. The Soviet Union, America's ideological adversary in the Cold War, had achieved the unthinkable. They had launched a 184-pound polished metal sphere into orbit around the Earth. It was called Sputnik 1. As it circled the globe, it emitted a simple, steady, and utterly terrifying series of beeps. This was no mere scientific instrument, it was a ghost in the sky, a constant, audible reminder that the United States was not the undisputed technological leader of the world. The beeping signal from Sputnik could be picked up by amateur radio operators everywhere. It was a transmission that crossed all borders, a message of Soviet supremacy broadcast directly into American homes. The psychological impact was profound and immediate. It created a wave of public fear and anxiety, a sense of vulnerability that the nation had not felt since the attack on Pearl Harbor. If the Soviets could place a satellite in orbit, what else could they do? Could they arm it with a nuclear weapon? The sky, once a symbol of freedom and infinite possibility, now seemed to hold a potential threat. This event triggered what became known as the Sputnik crisis. Headlines screamed of a technological Pearl Harbor. Politicians demanded action, and educators questioned the American school system, wondering if it had fallen behind its Soviet counterpart. The panic was not just about a single satellite, it was about a fundamental shift in the global balance of power. In the frantic search for an American response to Sputnik, a critical choice had to be made. The nation had 2 primary teams capable of launching a satellite. On one side was the United States Army's Ballistic Missile Agency, led by the brilliant but controversial German rocket scientist Wernher von Braun. His team, composed of veterans from the German V-2 rocket program, had a powerful rocket, the Jupiter C, ready to go. They were confident they could launch a satellite within months. This was a military-derived program, born from the technology of warfare and designed for power and reliability. On the other side was the United States Navy's Project Vanguard, managed by the civilian scientists at the Naval Research Laboratory. President Dwight D. Eisenhower's administration had chosen Vanguard back in 1955 to be America's contribution to the International Geophysical Year, a peaceful global scientific collaboration. The choice was deliberate and deeply symbolic. Vanguard was meant to represent a different path into space. It was to be a purely scientific civilian-led effort, divorced from the ominous overtones of military rocketry. Eisenhower wanted to establish the principle of freedom of space, where scientific satellites could orbit peacefully above national territories without being seen as a threat. The decision to stick with Vanguard, even after Sputnik, was rooted in this grander vision. Using von Braun's military rocket might have been faster, but it would have sent a muddled message. It would have framed the American entry into space as an explicitly military reaction, escalating the Cold War tensions. The Eisenhower administration hoped to draw a clear line between peaceful scientific exploration and the development of intercontinental ballistic missiles. Vanguard, with its new, custom-built rocket, was the perfect symbol for this idealistic approach. It was a project designed from the ground up for science, not for war. This choice, however, placed Project Vanguard under an almost unbearable strain. It was a research and development program, not an operational one. It was designed to proceed with careful, methodical steps, not to be rushed into a high-stakes race against a determined rival. Project Vanguard was not only facing immense political pressure, it was also grappling with significant technical and financial hurdles. The program was, by design, an exercise in innovation. The Vanguard rocket was not a modified military missile, but a completely new three-stage launch vehicle. Each stage presented its own unique set of engineering challenges, from the liquid-fueled first stage to the solid propellant upper stages. The goal was to create a rocket that was precise enough to place a delicate scientific instrument into a stable orbit, a feat that required a level of finesse far beyond that of a ballistic missile. The satellite itself was a marvel of miniaturization for its time. Nicknamed the Grapefruit Satellite, it was a tiny sphere just 6.4 inches in diameter, and weighing a mere 3.25 pounds. Despite its small size, it was packed with sophisticated technology. It carried two radio transmitters, one powered by mercury batteries, and the other by a revolutionary new technology, solar cells. This was a pioneering effort to create a satellite that could continue to transmit data for years, long after its batteries had died. This focus on long-term scientific value was a hallmark of the Vanguard project's philosophy. However, this ambitious scientific agenda was being pursued with a relatively modest budget. The program was chronically underfunded compared to the massive resources being poured into military missile programs. The engineers at the Naval Research Laboratory had to be resourceful, often working with limited components and pushing existing technology to its absolute limits. They were a team of dedicated civilian scientists, driven by a passion for discovery, but they were competing against a Soviet program that had the full and unconditional backing of the state. It was a classic David and Goliath scenario, with Vanguard scientists trying to achieve a monumental task with limited means. The pressure cooker environment was further intensified by the computing demands of the project. To track the rocket and predict the satellite's orbit, Vanguard relied on cutting-edge technology from IBM, including the powerful IBM 704 mainframe computer. This system was essential for calculating the complex trajectory needed to achieve orbit. Every launch attempt was a delicate dance between raw propulsive power, precise guidance systems, and the abstract calculations of the mainframe. The team was pushing the boundaries of rocketry, electronics, and computation simultaneously, all under the harsh glare of the global spotlight. It was a monumental undertaking, and there was absolutely no room for error. The morning of December 6, 1957, dawned with a heavy sense of destiny at Cape Canaveral. The entire nation was watching. This was America's moment of redemption. After 2 months of enduring the relentless beep-beep-beep of Sputnik and the international headlines about Soviet superiority, Vanguard TV3 was set to even the score. The launch was broadcast live on television, an unprecedented move that really underscored the immense public investment in its success. Reporters from every major news outlet lined the press sites, their notebooks open, and their cameras ready to capture the image of America soaring into the heavens. The final countdown was flawless, a testament to the meticulous preparation of the NRL team. As the voice over the loudspeakers called out the final seconds, a hush fell over the Cape. At T0, the rocket's first stage engine ignited with a deafening roar and a brilliant flash of flame. For one glorious heart-stopping moment, everything seemed perfect. The rocket lifted off the pad, a vision of grace and power. It rose to a height of about 4 feet, clearing the launch structure. In living rooms across America, a collective sigh of relief and a budding sense of pride began to swell. This was it. Then, in an instant, the dream dissolved into a nightmare. A sudden loss of thrust in the rocket's engine caused the vehicle to lose its upward momentum. It hung in the air for just a fraction of a second before gravity reasserted its dominion. The sleek rocket, moments before a symbol of ascent, tilted clumsily and fell back toward the place of its birth. It struck the edge of the launch stand, and its thin-skinned fuel tanks, filled with a volatile mix of kerosene and liquid oxygen, immediately ruptured. The result was a cataclysmic explosion that sent a mushroom cloud of black smoke and fire billowing hundreds of feet into the air. The launch pad was transformed into a raging inferno. Debris from the shattered rocket was flung across the area, and amidst the wreckage, a small battered object was thrown clear of the flames, the Vanguard satellite. Its tiny radio transmitter, miraculously still functional, began to beep, a pathetic and mournful cry from the heart of the disaster. The journalists who had come to report on a triumph were left to describe a spectacular and humiliating failure. The live television broadcast captured it all, searing the image of the exploding rocket into the national consciousness. America had not reached for the stars, it had stumbled at the starting line. The failure of Vanguard TV3 was not just a technical malfunction, it was a public relations catastrophe of global proportions. The explosion was seen and heard around the world, and the reaction was, well, swift and brutal. In the United States, the initial shock gave way to a deep sense of national humiliation. The live broadcast had turned millions of Americans into first-hand witnesses of their country's failure. The image of the exploding rocket became an instant symbol of American inadequacy in the face of the Soviet challenge. The nation's confidence, already shaken by Sputnik, was now completely shattered. The international press was merciless. Newspapers in London, Paris, and beyond ran headlines that dripped with mockery. They coined a host of derisive nicknames for the failed project: Flopnik, Kaputnik, Stayputnik, Dudnik. The clever wordplay really captured the essence of the disaster. America's high-tech ambition had collapsed in a fiery heap. Soviet delegates at the United Nations wryly asked their American counterparts if the United States was interested in receiving aid under the Soviet program for underdeveloped nations. The laughter echoed from the halls of power to the streets of Moscow, amplifying America's embarrassment. The failure was a propaganda gift for the Soviet Union. It reinforced their narrative of a dynamic, forward-looking communist system that was rapidly outpacing a decadent and faltering capitalist West. Soviet Premier Nikita Khrushchev, who had already boasted about Sputnik, could now point to Vanguard as further proof of his nation's technological superiority. The contrast was stark and undeniable. While Soviet rockets successfully climbed into orbit, America's blew up on the launch pad. The failure undermined American prestige and weakened its position in the eyes of allies and unaligned nations around the world. For the American people, the event was a moment of profound soul-searching. The optimism of the post-war era gave way to a nagging sense of doubt. Were American scientists and engineers really the best in the world? Was the American education system failing to produce the talent needed to win the Cold War? The Vanguard explosion was more than a failed rocket launch. It was a blow to the nation's self-image. It created an urgent, undeniable consensus that something had to change. The country could no longer afford to be second place in the race for space. The humiliation had to be turned into motivation. In the immediate aftermath of the Vanguard disaster, the mood in Washington was, honestly, pretty grim. The Eisenhower administration faced a storm of criticism from Congress and the public. The decision to rely solely on the civilian Vanguard project now looked like a monumental blunder. The humiliating failure on live television demanded a swift and decisive course correction. The investigations into the technical cause of the explosion, a low-pressure reading in the fuel system, were frankly secondary to the urgent political need to get an American satellite into orbit as quickly as possible, by any means necessary. All eyes turned to the United States Army and Wernher von Braun's team at the Redstone Arsenal in Huntsville, Alabama. For months, they had been waiting in the wings, their Jupiter C rocket essentially ready to go. Von Braun had famously claimed after Sputnik that his team could have launched a satellite 60 days earlier if they had been given the green light. Now, in the wake of Vanguard's failure, their moment had finally come. The political barriers that had favored the Navy's civilian project over the Army's military-derived one evaporated in the heat of the public outcry. The Department of Defense acted with lightning speed. Just days after the Vanguard explosion, Defense Secretary Neil McElroy officially authorized the Army to proceed with their satellite launch attempt. The pressure was now transferred to von Braun and his director at the Jet Propulsion Laboratory, William Pickering. They were given a tight deadline: launch a satellite within 90 days. For the Army team, this was the opportunity they had been craving. It was a chance to vindicate their work, to prove the capability of their rocket, and to salvage their nation's pride from the wreckage of Cape Canaveral. The effort was given top national priority. Resources that had been scarce for Vanguard were now made readily available to the Army's project. A new sense of urgency swept through the program, which was officially named Explorer. The team at JPL, under the direction of Pickering and with instrumentation designed by scientist James Van Allen, worked around the clock to prepare the satellite. Meanwhile, in Huntsville, von Braun's rocket engineers meticulously prepped their modified Jupiter-C launch vehicle, now designated the Juno 1. The ashes of Vanguard's failure had become the fertile ground from which a new, more urgent American space effort would rise. On the night of January 31, 1958, less than 2 months after the Vanguard catastrophe, all the hopes of a nation once again rested on a single rocket at Cape Canaveral. This time, it was the Army's Juno 1, a tall, slender missile with the Explorer 1 satellite tucked into its nose cone. The atmosphere was tense, but it was a different kind of tension, one born of desperation and a fierce determination to succeed. There was no live television broadcast this time. The government was not going to risk another public humiliation. Only the key personnel and a handful of reporters witnessed the countdown. At 10:48 p.m., the Juno 1 rocket roared to life and leaped off the launch pad. It climbed flawlessly into the dark Florida sky, a perfect, unwavering streak of fire. On the ground, the launch team held its breath, tracking the rocket's progress as it soared higher and higher. The crucial minutes passed. The rocket performed exactly as designed, with each stage firing in perfect sequence. But the real confirmation of success would have to wait until the satellite completed its first pass over the Earth, and its signal could be picked up by tracking stations in California. The wait was, honestly, agonizing. Then, just before midnight, the confirmation came. A tracking station had picked up the signal from Explorer 1. It was in a stable orbit. In the makeshift control center, William Pickering, James Van Allen, and Wernher von Braun held a model of the satellite aloft in a triumphant press conference. America was finally in space. The news flashed across the country, and a wave of relief and jubilation washed over the nation. The success of Explorer 1 did more than just place a satellite in orbit. It discovered the Van Allen radiation belts, a major scientific breakthrough that was the first great discovery of the space age. The back-to-back experiences of Vanguard's failure and Explorer's success taught Washington a crucial lesson. A fragmented inter-service rivalry was no way to run a space program. The nation needed a single, unified civilian agency dedicated to peaceful space exploration, one that could harness the best talent from both civilian and military programs and focus it on a common goal. In July 1958, President Eisenhower signed the National Aeronautics and Space Act into law, creating the National Aeronautics and Space Administration, NASA. The new agency absorbed the core of the NRL's Vanguard team, von Braun's Army Rocket Group, and other key research centers, forging them into the powerful organization that would one day reach for the moon. In retrospect, the fiery demise of Vanguard TV3 was not the end of a story, but the painful, necessary beginning of a much grander one. Failure is a powerful teacher, and the lessons learned from that disastrous December day were profound. The explosion taught America about the unforgiving nature of rocketry, where the smallest malfunction can lead to catastrophic consequences. It exposed the folly of underfunding ambitious technological projects and the danger of allowing inter-service rivalries to dictate national strategy. Most importantly, it shattered the nation's complacency and ignited a fire of resolve that would burn for more than a decade. The legacy of Project Vanguard itself is more complex than its most famous failure. On March 17, 1958, a subsequent rocket, Vanguard 1, successfully reached orbit. It was the first satellite to be powered by solar cells, and it continued to transmit data for over 6 years. As of today, it remains the oldest human-made object still orbiting the Earth, a silent testament to the project's innovative spirit. Ultimately, the road to the moon began not with a triumphant leap, but with a spectacular fall. The Vanguard explosion was the shock that awakened a sleeping giant. It created the urgency that founded NASA, funded the Gemini program, and fueled the political will for President John F. Kennedy's audacious challenge to land a man on the moon before the end of the 1960s. The image of Neil Armstrong's boot stepping onto the lunar dust in 1969 is inextricably linked to the image of the Vanguard rocket collapsing in flames 12 years earlier. One could not have happened without the other. It was a classic Phoenix ascent. From the fiery ashes of a Florida launch pad rose the ambition and determination that would carry humanity to another world.